again, the first thing I want you to write down as a note, all right? Now, as you progress in math, the higher you get, we don't really talk about square roots or cube roots. We write them as, we say, rational exponents, all right? So the first thing I want you to remember is this. You need to take this note down, that the 1 in the numerator represents the exponent. That's what I want you to write. The 2 in the denominator represents the root. All right? So the 1 represents the exponent, and the 2 represents the root. All right? So in this case right here, I have, or that is the same as the square root of 12. Now let me show you where those numbers are. 12 is to the first power, and the square root, that 2, believe it or not, is an understood 2. Do I have to write the 2 there? No. You'll even see on your calculator, they don't put a 2 out in front. But I will show you the place where there is a cube root, all right, that they do put the 3 out there. And I'll show you they put the 4 out there. All right, so right now, I want you to understand when I say 12 to the 1/2, that is exactly the same as the square root of 12. Now, I'm not asking you to use your calculator right now, because right now I'm just simply showing you how to translate from one form to an equivalent form. Right now, we're going from an exponential form to a radical form. All right, so if I look at question number 2. Now, on question number 2, I need you to highlight or just make sure you're aware, the only thing that is to the 1/2 power is what? X. That is correct. Because 3 has its own power, and that's a what? That's a 1. So the correct answer for number 2 would just simply be 3 radical x. Now again, if you want, just to make sure you're hearing me, the 1 is that, and the 2 is that. All right? Now let's take a look at number 3. Now we're going to write it as an exponential. So I say the square root of 33, that can be written as what? What can that be written as? 33 to the 33 to the 1/2 power. Thank you very much. 33 to the 1/2 power. That can be 33 to the 1/2 power. Now listen, boys, you guys are already way behind. All right, way behind. I don't know why are you guys so late?
We had to clean up the inside and outside of the lunch.
All right, yes.
Why would how do you have it would be to the 1/2 power?
Well, because we looked at question number 1. All we're doing is it's the same. We're going in the reverse order now. 12 to the 1/2 is the same as the square root of 12.
So they're all going to be to the 1/2?
No, don't make any generalizations right now. This right here is a 2. This right here is a 1. The power is the numerator. The root is the denominator. And I'm going to give you another example here in a minute just to make sure we're understanding. All right? Take a look at number 4. So if I was going to write that as exponential, both 8 and n are under the radical, so you would say that is simply 8n raised to the 1/2 power. That is correct. 8n raised to the 1/2 power. What? Oh, just come on. What do you think? When was the last time I taught you something that wasn't on a test? Come on. Those are just, you're going off to high school. I don't want you to raise your hand and ask your teacher, is this going to be on the test? Everything that's presented is usually on the test. All right? Now, I want everybody to write this down. If I said the cube root of x, how do I write that? X to the 1/3. Thank you very much. X to the 1/3. Very good. All right. Now, what if I did, for example, the 5th root of y to the 4th? What would that be written as? Go ahead. No. No. Come on. Look up here. Look at my example. Put your hands down. Stop talking. I want him to think. All right, I want you to look at the first one. Yeah, now what we're trying to teach you is you go too fast. You want to be the first one done, and I would much prefer that you slow down and think about what you're saying. I'm showing you patterns. You're smart enough to get the patterns. There's no reason to hurry. None. Think about it before you speak. Y to the 4/5. That is perfect. All right? Now, one more example. The 7th root of x to the 10th. What is that?
It's x 7 or 10 over 7.
That is exactly correct. So now everybody understands what I'm doing. All right? The root, listen to me, the root. Notice where the root is. The root is the denominator. Notice where the what? The exponent is. To the 1st, 4th, 10th. That is the what? That's if you got your hand up, you're not listening to me. Look up and tell me, right? I'm showing you. All right, now I'm asking you to understand those 3 problems.
Yes, sir.
All right, good. And then we'll go on. What now?
So will the problems like look like that? Because like the other ones.
I'm not there yet. I promise you. In 30 minutes, you're going to go, wow, that was the easiest thing I've ever done. I promise you. Everybody's left today going, wow, that was really easy. And we're going to be done in 30 minutes. All right, but I have to train you first. I have to get you to think about something. All right, we're doing it a little bit differently. Put your hand down. Goodness. All right. Now, number 5. All right, now here's where you need your calculator. Because most people don't know the cube root of 512 is 8. All right? So because you don't know the cube root of 512 is 8, I need to show you on your calculator. So here's what we got. Take your calculator in your hand, and I want you to hit the math button. And now you will notice a bunch of radical signs come up. We're interested in number 4, so hit 4. And then you type in 512. All right? Type in 512. And when you type in 512, you get what? You get 8. All right? Everybody okay with that? Now, I need to help you right now if you don't see that. Did you do that on your calculator? You still eating? You did it on your calculator. All right? I don't care what page it is. All right? Now, the next thing is I want everybody to type in 512. Type in 512. Then you hit the caret button. And the caret button is, you know what that is. And then you type in 1 divided by 3. And what comes up on the calculator? 8. Same thing. So I'm showing you, if I was designing the calculator, I wouldn't put the math 4 in. Why? Because it's, to me, quicker just to raise it to a power. Is everybody hearing me on that? The more advanced you get in math, we don't use the square root symbol anymore. We just write it as an exponent. All right? So right now, though, we're going to learn both ways. All right? Anybody have any questions? All right. Now, what I want to do is we're going to show you how to do the 5th root of 243, because like I said, most people don't know that that is 3. Very good. All right? 3. Brilliant. So what I want you to do now is I need everybody to hit a 5. 5. And then I need you to hit the math. Now, I want you to go down instead of 4, but I need you to go to number 5. Now, see that X is out there, right?
Oh, yeah.
So then if you hit 5, then it automatically changed it to 5th root. Does everybody agree with that?
Yeah.
And then type in 243. And you still get 3. Now, the next thing I want you to do is I want you to type in 243 caret 1/5. All right? And that's both ways. Okay. You got him? Will? Did you help? Did you show him?
Yeah.
You good or not?
Yeah.
All right. So now this is equal to, this was equal to 3. Like I said, today's big lesson is to make sure you know how to use your calculator better. All right, we don't just do square roots. We do cube roots, fourth roots, fifth roots. All right, so now on number 7. Everybody type in for number 7. 343 caret 1 divided by 3. And of course, everybody knows that's 7. All right, I told you, very easy. All right, now, again, remember, I want everybody to say for question number 7, that is 343 to the 1/3 power. Does everybody agree? Or we could say that's the cube root of 343. Those are your options. All right, exponential is called the first way. The cube root is the second way. All right, now, for number 8, sometimes you're going to make a mistake. The whole quantity is being raised to the 1/16. So it'd probably be better if you put parentheses around it. All right, so put parentheses around it, raise it to the 1/4. Now, we really don't operate with decimals.
So it should be 1/2.
Yes, so if you forgot how to convert to a decimal, to a fraction, math, enter. All right, I know everybody here knows 0.5 is 1/2, but I'm saying for your calculator, math, enter, and it will convert a decimal to a fraction. So we said number 8 was what? 1/2. Everybody good?
That's so cool.
All right, it's very cool. All right, it will help you out a lot when you're taking standardized tests if you know how to do this. All right, now let's check out number 9. 343 to the 2/3.
49.
Is everybody agreeing with me? It's 49.
Yes.
All right. And then, of course,
10 is 27.
81 to the 3/4 should be what?
27.
Should be 27. And then, of course, everybody knows 216 to the 4/3 is equal to 1296.
I didn't know that off the top of your head.
It's really easy. 216
Of course it is.
times 6. Look, really. 216 times 6 is all that is. What's 2 times 6? 12. What's 16 times 6? 96.
How do you times 6?
Right, because I
Your mind is
knew
just a
that the
calculator.
cube root, no, the cube root of 216, I've done it enough, that's 6.
Your mind is crazy.
No, I promise you, you do it enough. I'm expecting you to know those numbers. Look, and that's what I'm trying to tell some of you guys. Listen to me. I'm not kidding when I tell you this. Listen. Right? If all you're doing is typing the number into the calculator, not thinking about it, then you're never going to know that 216 to the 4/3 is 1296. I'm trying to demonstrate how I knew it was 1296. Just like I knew that 81 to the 3/4 was 27. How do I know that? Because the 4th root of 81 is 3, and 3 cubed is 27. That's really not that hard. All right, but if you're amazed by that, listen to what I'm telling you. I'm telling you, I'm not that good with numbers. I just know how to manipulate the numbers so it's easier for me to see the solution. That is the key. All right, it has nothing to do with me knowing how to multiply 2 times or 216 times 6. I wish you would look up there and say, yeah, that's what he's saying. It's not really that hard. 2 times 6 is 12, and 16 times 6 is 96. It wasn't that hard. It looks hard if you never look at the numbers and try to figure them out. I'm telling you, that's the most important thing about you if you want to be good at math. All right? And does everybody hear anything about what we did on Mars recently?
It's like we
We just landed
yeah.
a spacecraft on Mars. Do you know
Wow.
how far Mars is from the Earth?
A lot.
800 million miles away.
That's a lot.
And we had a remote control on NASA, and we're controlling it to go through the atmosphere, which is nearly impossible, and then to land it on the surface. And some of you are asking me, why is math important? We are controlling it from Earth, 800 million miles away. And it takes, for those of you guys who know a little math, it takes 8 minutes for the signal to get from Mars to NASA. And so, you're telling it to move right, and it's about ready to fall off a cliff. You think it's possible to tell it to stop, it's going to go over a cliff. No, because it takes 8 minutes to communicate that fact. You also know it's drilling like 10 feet down to see what's going on underneath the surface. That's what I'm telling you. All right, we need people to be really good at math. It's not that difficult. It's not that difficult. All right? It's been like a week now.
Yeah, because I have this thing called the skim, and it
It's amazing.
It sums up the news, and I saw it like last week.
It is absolutely amazing. Absolutely amazing. And it's all math. All right? So here we go. Number 12. Now, again, no, I want it as a fraction.
1 over 343.
Yes, 1 over 343. 1 over 343. You hear me? All right. Again, very basic information with the use of a calculator. All right. Now, we're skipping these, and now we're going right down to 17 through 24 to see if I made sense. All right. So I want everybody in here to be able to write 15 to the 1/2 as a radical. So that would be written as what?
A fraction.
15 to the 1/2. I need to write it as a radical. What would that be? No. You're just simply writing as a radical. Sebastian, tell them what we mean.
Oh, it'd be like the square root.
Right. It's not like it is the square root of 15. It is the square root of 15. So when you write something to the 1/2, we're saying you could write it as the square root of 15. I'm not asking what the answer is. I'm simply saying we're converting from one form to the other. All right? So when somebody says 24 to the 1/2, Miss Brandeis, what is that? The same as?
It would be the square root, and then it would be 2 on the outside of
Yep.
24.
Yep.
On the outside, and then 1 next to it.
Exactly. Now, is it necessary to put 2 as the root and 1 as the exponent? No, it's just good to do that. Just because you're training yourself where the numbers go. All right, that's exactly right. Okay, so now, Julian, for 4k to the 1/2, is 4 considered part of the radical? No, very good. So the answer would be what? Square root of k, and then what would be on the outside of the radical? No, what else? 4. So that's the answer for number 19. That's the one that's kind of important. 4 radical k. Is everybody good with that? All right. Now, number 20. They're trying to show you a difference between 19 and 20. All right, Miss Danzy, this would be what?
The square root of 12.
That would be the square root of 12y. Anybody have any issues with that? All right. I'm listening. What? Hold up.
How come, like 19, you can have...
Now you tell me. You tell me what's the difference. Come on now. Remember, I'm trying to teach you about making observations. If you want to be smart, you got to look at the observations and tell me what's the difference. The parentheses. The parentheses mean that the whole thing is under the radical. If it doesn't have a parentheses, it just means that this is under the radical. That's all. That's it. That's the difference. Remember what I'm trying to tell you. Try to look for patterns on your own. See if you can make a generalization of why it's true, and then test out your theory to see if it works. All right, for question 21. So Hanson, square root of 26 can be written as what? As an exponential.
Would it be
26 to the what?
26 to the 1/2?
Yes, 26 to the 1/2. Cole, 22 would be written as what? 44 to the 1/2. Beautiful. And then 23. Go ahead. 2ab to the 1/2. Now, I want everybody to write it like that. And then I want everybody to write underneath that. We could write it as 2 to the 1/2 and b to the 1/2. Everybody should know that. Go ahead, tell me.
I don't understand why.
Why what?
Why we would do, why would like the A have a second would happen and the B would have a second. I don't understand.
Well, because the A and the B are under the radical.
So why do they each have a separate 1/2?
Well, you could just write it either way. Because, hey, I'm still working. You're tapping me. All right? What's under the radical means it's to the 1/2 power. So is A under the radical.
Yeah.
So that means A is to the 1/2 power.
Okay.
If b is under the radical, it's also to the 1/2 power.
Okay.
Or you can just write it with parentheses. All right? And finally, 24. Tell me. Go. Yes, me.
It would be in parentheses 3 x, y, z,
Yes, 3x, y, z to the 1/2. Perfect. Yes.
Why is 3?
It's 3 under the radical. All right, if it's under the radical, it's raised to the 1/2. Now, underneath that, I would like everybody to write 3 to the 1/2, x to the 1/2, y to the 1/2, z to the 1/2. All right, that's another way of writing it. All right. Now, I'm going to put it on pause just for a quick second. Okay, 25. We'll go back here. Connor.
8 and
The cube root of 8 is what?
1/3.
I don't have any idea what you're doing. 25. Shh. The cube root of 8. Type it in on your calculator.
Oh. 8.
Shh.
500.
No, you just did 8 cubed. 8 cubed is 512. Hit math. And then go down to 4. And then type in 8. Come on. That's what I'm saying. No room to be funny. No time. You got work to do.
I tried to
Okay, hold on.
Breathe, Abby, breathe.
Well, you didn't give me your
She must drool a lot.
I want the ice.
Dude, you're so.
Doesn't matter.
She can have 42.
She must drool like a lot.
Okay.
Oh, okay.
Right. Okay, number 26.
26 was 4.
26 is 4. That is correct. All right. 27. Here we go, Caroline. Which is what? That would be 6. That is correct. All right. 28. You're up, Abby.
That would be 5 point.
Wait a minute. The 4th root of 1,000. Type in the 4th root of 1,000.
Oh wait, I did it wrong.
Listen to me. Raise your hand if you have a question. I don't want to hear your noises anymore either.
Yeah, 5 point.
The 4th root of 10,000.
Oh.
The 4th
Yeah,
root of
that's
10,000. Come on, come on.
Okay. 10.
29. Here we go. Cube root of 0.001. I'm just going right around the room. 0.1 is correct. All right.
Wouldn't it be like 1/10?
Yes, if you want, you could write it as the fraction 1/10. Perfect. But generally, if the answers or if the question is in a decimal, I don't care about leaving it as a decimal. Guys, boys, I'm just telling you, man, I'm losing my patience. Julian, you think things are funny? I'm just telling you right now, it's not funny. You hear me? Will, you got me? I'm not kidding. I'm asking you to stop, and if it's not, I'm walking you to the office. All right? I'll leave the whole class here, and I'm going to take you boys to the office and demand your parents come to the school right now. Julian, you hear me? I'm tired of you thinking things are funny. I want to get this done. 30. Math, enter. 2/3. Sebastian. 31. 32. Julian. 33. Miss Rodriguez. 33. You know what you're doing? I don't see a calculator in your hand. You should be doing all of them on the calculator. Every single one. Not writing down the answer. It's no value just writing down the answer. What is it again? 15. Perfect. All right, Carly.
For
34.
2.
Very good. 35. Caroline.
I got one.
This one. We're going right in order.
I got 1/3.
1/3. Cole, 36. Thank you very much. That was a good one. 5/2. All right. Any questions? All right, Will, 37.
37.
Good. Hanson, why don't you just tell me what 38 is?
I wasn't sure because I wasn't hearing you tell it. So how do you
Stop making excuses. I've been doing all these on every single one of them. At any point, you could have said, "Hey, stop for a second and just show me what you're doing."
see you do the one?
I'm asking you to type in on your calculator 625. Cole, I'm not sure if you didn't hear what I just said a few minutes ago. You're not far. All right, and I got your parents on my email continuously. Nothing's funny about someone who doesn't know anything to do or how to do this problem and been here for 30 minutes. It's not funny. I'm not sure what you're having trouble with. Type in on your calculator 625 to the 3/4 power. There's this little button you have to find. It's called the caret key.
125.
What is difficult about that?
I knew how to do all the other ones. I just wasn't sure because when I was in here, we didn't do problem with the
Once
power.
again, all of that to me is an excuse. I didn't tell you what to do on any of it. You just told me the answer was 125. So you're in good shape, right?
Yeah.
But you're in good shape, right?
Yes.
Okay, we're moving on. Caroline, 39. 243. Anybody having issues with that? 243. All right, Connor, number 40.
Isn't that 1.5?
Number 40. 256 to the 3/8 power.
Oh, it's 8. My bad.
41.
41 was 625.
Thank you. And 42.
49. That's going to be 1,600.
800 what? All right. That's correct. Everybody good on that? Final.
I got 0.02.
No, math, enter. I want is it a fraction?
27/1,000.
27/1,000. And last, you're up.
Oh, 8/625.
Did you put it in parentheses? Yes, if you don't put it in parentheses, you'll have the wrong answer. Just a minute, let her get the answer out.
Okay, 16/625.
That's correct. 16/625. All right. Now again, what you're supposed to say is that was pretty easy. All I'm trying to do is trying to show you how to use your calculator a little bit better. That's all. All right. Don't worry about being on the test. It's straightforward. Well, I'm just going to put 4 or 5 questions. You know, very easy. You're allowed to use your calculator. All right, so it's not that big of a deal. Now, hold up, because I still have something else I need to say. All right.